Alright, so good afternoon. Today we're going to look at question 15, tutorial sheet 3, MSM 131. Okay, it says find the roots of the quadratic equation subject to the given condition. So for us to find the quadratic equation that is subject to the given condition, what do we need to do? So simply we need to know the condition that has been started. So I'm only doing the first question, which says x plus k squared is actually equal to two minus 3k. So x plus k squared is equal to 2 minus 3k. Right, so the first thing I'm going to do is I'm going to rewrite this plus 3k is equal to 0. Alright, so whenever you face or encounter such questions, what you need to understand is that you need to find the sum and the products of a particular quadratic equation. So in this case, we know that we cannot find a, b, and c because this thing here has not yet been expanded. So we're going to expand that. If you expand it, it's going to be x squared plus 2kx plus k squared minus 2 plus 3k is equal to 0. So what is the sum? The sum of the roots, in this case, the roots that we've been given is alpha and alpha. So we have 2 alpha. So we have the roots according to the question, okay? According to the question, it says alpha and alpha, right? Because we've been told that the roots are equal. So the sum of the roots, we know that alpha plus beta is equal to negative b over a, right? So in this case, we know that the b is 2k, so over 1, so the answer is negative 2k. Then the product of the roots, is found as c over a, so we have k squared plus 3k minus 2 as our product. Alright, so from here now the next thing that we're going to do is we now need to put it in the stated condition. So the stated condition says that the two roots are actually equal. So meaning if the first root is alpha, the next root will also be alpha. So meaning that we have the sum of the roots as alpha plus alpha, right? So the sum of the roots is alpha plus alpha, so we have alpha plus alpha, which is equal to negative 2k. So you have 2 alpha is equal to negative 2k. If I make that alpha the subject, we have alpha is equal to negative k. So this is my equation 1, right? So that's my first root. My next root is going to be the product. So alpha dot alpha, or alpha times alpha, is equal to c over a. But we know that the product of the roots was given as k squared plus 3k minus 2, right? Then we have alpha squared is equal to k squared plus 3k minus 2. So this is now my equation 2. So this is part 2. Okay? From this now, we know that our equation 1 says k alpha is equal to, so I'm going to replace into equation 2. So 1, replacing into equation 2, we have negative k squared is equal to, because alpha here we've been told that alpha is k, alright? So alpha is negative k, so we have k squared plus 3k minus 2. Alright, so we now have k squared is equal to k squared plus 3k minus 2. If the k goes the other side, you have k squared minus k squared plus 3k minus 2 is equal to 0. This and this will cancel, so we have 3k minus 2 is equal to 0. 3k is equal to 2 over 3 over 3. So k is 2 over 3. Okay, that's the answer. K is equal to 2 over 3. So we have k squared is equal to k squared plus 3k minus 2. Okay, so that is what we have there. End of question. Question 16. Okay, so that suffices question 15. Okay, so let's look at 15C. 15C. 15C is saying that k squared minus 1 plus xk 1 plus kx plus 3k plus 2, okay, has the sum of its roots equal to twice the product of its roots. Has the sum of its roots equal to twice the product of its roots. Alright, so meaning that it has the sum of the roots twice the product of the roots. Alright, so in this case what we get is, we know the sum of the roots is found as negative b over a. In this case we have negative, the coefficient of x here is the b, so we have negative 1 plus negative plus k over 1, which is just 1 plus k. Okay, so alpha plus beta is 1 plus k. Then what have we been told? The sum of the roots is actually twice the product of the roots. We have the sum of the roots being equal to twice the product of the roots. Okay. Tutorial sheet 3, MSM 131. So we're solving tutorial sheet 3, T3. Alright, so tutorial sheet 3, we are now on question 15. I'm doing 15C. Alright, so from there, we know that the sum of the roots is twice the product of the roots. So what is the product of the roots? So meaning that, let's continue that. Let's find the product first. The product is C over A. Alright, so C here is 3k plus 2 over 1. So meaning the product of these roots is actually just 3k plus 2. Okay, so the product is 3k plus 2. Now you've been told that the product is actually twice. You've been told that the product is twice the sum. Okay, you've been told that the product is twice the sum. So it has the sum of the roots equal to twice the product of the roots. So we have alpha plus beta is equal to 2 alpha beta, right? So the sum of the roots is equal to twice the product of the roots. But do we know what the sum of the roots are? Yes, it's 1 plus 1, k. Do we know what the product is? The product of the roots is 3k plus 2. So now we have 1 plus k is equal to 6k plus 4. Alright? So that is what we get there. Then from there we now have 6k plus 4 minus. So if I can actually take this the other way, collecting like terms together, you have 6k minus k is actually equal to, so 6k minus k is equal to 1 minus 4, alright? Then we have 5k is equal to negative 3 over 5 over 5, so k is negative 3 over 5. K is negative 3 over 5. So all I did was 6k minus k is 5k, and 1 minus 4 of, 1 minus 4 is negative 3, so the answer is negative 3 over 5. So that is what we have as our final okay, negative 3 over 5. So the basic knowledge on this question is simply, we need to write this according to the stated condition. So the stated condition said the sum of the roots has got twice the product of the roots. Now, I always mention this, and I say whenever you are dealing with questions to do the roots of quadratic equation, always find the sum and the product of the roots, regardless of what you are looking for, all right? So before you even answer any question, find the sum and the product, because the sum and the product of the roots is always, or usually is used, okay? Usually is used to answer the concurrent question or the question that follows. So in this case, we were told that the sum of the roots is twice the product. So even before I did that, I needed to find the sum of the roots. So the sum of the roots, alpha plus beta, is negative b over a. So what is b? B is negative 1 plus k, right? So this is b. So replacing that negative, it becomes positive. So this is why you have 1 plus k. All right. Then from there you have alpha times beta is equals to c over a, which is equals to 3k plus 2 over 1. So we have alpha times beta. Yeah, so we have the product of the roots being equals to 3k plus 2. But what is this question stating? We are looking for k which satisfies the given condition. What is the condition that has been stated? The condition in question is that the sum of the roots should be equal to twice the product of the roots. So the sum of the roots we have is 1 plus k from here, and the product should be twice. Okay, so we have the product as 3k plus 2, so I multiply that by 2, and this is what we have, 6k plus 4. Then I simply solve for k. The k ends up being k is equals to negative 3 over 5, right? So that ends that question. Question 16. So we have 3x squared plus 13x plus 4 is equals to x plus 4 multiplied sum a polynomial. Alright, so we have been told that when you multiply 3x squared, this is now question 16. Alright, so the first question is, if you multiply x plus 4 times some polynomial, getting this thing that is on the left hand side. Alright, so now the question is, what is the stated degree for the unknown polynomial? So whenever you hear the word degree, we're simply looking for what is the number that is on the highest powered variable in the expression. Okay, so for instance, what is the degree of a cubic function? It's 3. Because the highest x variable there has got power 3, okay? So we are simply asking for the highest power in the given function, all right? So the highest power in the given function. So in this case, the function that has been given is x squared, meaning that the highest power is 2. So the degree for this function is 1, is 2 for the polynomial, okay? So the degree for this polynomial is 2. Now we're saying if you multiply x plus 4 times some polynomial, it should give you whatever is on the left hand side. So now, what should be the highest power of x in the unknown polynomial for you to get squared here? It should be x, so it should be power 1. So meaning the degree of the unknown polynomial is simply 1. Okay, so we're saying the degree for the unknown polynomial is 1. Why? Because when you multiply the given polynomial, which is x plus 4, if you multiply x times this polynomial, you should have the highest power of 2. So meaning that one has the highest power of 1. So in short, the polynomial is actually a straight line. So remember, a straight line equation is given as yx plus c, right? So I can actually write this as x plus 4 multiplied by mx plus c. Alright, so that is that. Then from here now, we're saying this should be equal to the other side. So it should be equal to this quadratic equation. So we're saying 3x squared plus 13x plus 4 should be equal to x plus 4 multiplied by mx plus c. Alright? So now the first question we've been asked is, can you calculate the value of the coefficient of x. So what is the coefficient of x in the unknown polynomial? So now remember that I cannot tell the coefficient of x from here because I've not expanded it. So in short, they're looking for m, right? So we're looking for m. So I'm going to say x times m. So we have mx squared plus x times that. This is cx. 4 times mx, we have 4mx plus 4c. Alright? So this which I have here is what we're calling the unknown polynomial. So this is equal to 3x squared plus 13x plus 4. Alright? So now, remember that the value I'm looking for here is simply m. The coefficient of x is m. So if I compare these two, 3x squared plus 13x plus 4, alright? That is what we have. So now, what is m? If you compare, this one should actually be mx squared oh yes, so let's write it properly. Okay, so if you compare these two, alright, what's the coefficient of x squared? So you notice that 3x squared is actually equal to mx squared. So what is m? M is 3. That's all. Alright. So meaning the coefficient of x in this unknown polynomial is m. And what is m? It's 3. Alright, so that's your answer. Next up, what is the coefficient of x in the unknown polynomial? We found this. Determine the polynomial. Alright. So now we want to know what the polynomial is. Now the polynomial is mx plus c. Now we need to find the value of c. We can find c in two ways. Number one, if we are comparing this left hand with the right hand, what do you notice? Notice that you have a constant 4c. So 4c here, then there's cx here, but the c is not independent of here because this thing here can be written as mx squared plus open bracket c plus 4m. I factored out the x plus 4c. Alright? So we can write that as that. Right, so this is another way of writing it. But as I was saying that we cannot actually find the value of c because it's not independent of m. Alright, so we have two ways we can find c we have two ways we can find c from here. Either we can equate c plus 4m to 13x because that's the coefficient of x. Alright? Or we can actually look at where is c. C is, we have 4c here, which is a constant, the variable without an x. We have a variable without an x here, which is actually 4. Right? So we will notice that you have 4c is actually equal to 4. Alright? But I will not use that because it's too easy. Let's use something more complicated. So we're saying 13x is actually equals to c plus 4m then x. Alright? But do we know what, so meaning that 13 here is actually equals to c plus 4m. Alright? From that we can solve. Do we know what m is? Yes, we found m. So m is actually 3. Alright, so we have 13 is equals to c plus 12. So what is c? C is 13 minus 12. C is equals to 1. Okay, so that's the value of c. C is actually 1. That's our value of c. So my c ends up being a 1. Now that I know that c is 1, what is the given polynomial? So the given polynomial was mx plus 1. C. Do we know what m is? M is 3. X plus what is c1? So this is the polynomial in question, 3x plus 1. That ends the question. So we're saying you simply replace the values of m. So from this stage, we're saying 13x is equals to c 4m, okay? C plus 4m, x. So now the coefficient of x here is 13. and the coefficient of x here is c plus 4m. So I simply equated the two. So 13 here is actually equals to c plus 4m. But we know that m is actually 3, so I replace the 3 to get to that. Okay, so that's that. Alright. Next question, I'm now going to question 16. Oh, we're done with question 16, question 17, right? 17 says the first one 3x to the power 4, so it's simplified these algebraic fractions, leaving the answers in the lowest term, so we're simply simplifying. Alright, so we have 3x to the power 4, alright, minus 21x over 3x. So that is what we have there. So here all I need to do is what is common in the numerator. You notice that 3x is common. What remains? X to the power 3 minus 7x. Then everything over 3x. Then this and this will cancel, so the answer is x to the power 3 minus 7x. Right, so that's the answer. X to the power 3. Next question. We have 2x squared minus 8 over 2 minus x. Right, so how do I solve for that? Okay, so I'm going to factor out what's common in the numerator. So we have 2x squared minus 4. Okay? Over 2 minus x. Alright? Then we know that the numerator now looks like difference of two squares, so we have 2x plus 2, x minus 2, over 2 minus x. Okay. From here, the next thing is we need to factor, if you look at this, there's a difference. X minus 2 and 2 minus x are different. Here the x is positive, the x is positive, the 2 is negative, the 2 is positive, the x is negative. So what do? In order for us to find the value of this, we need to make sure that this one look the same. So I can factor out a negative in the denominator, okay? Or, in the denominator. So doing that, we're going to have, so factor out a negative, we have 2x plus 2, x minus 2, over negative x minus 2. Okay, so I factored out the negative, so this and this can now cancel. What remains is negative x plus 2 as my final answer. Okay, so that's the final answer we should have. So that's how you solve that question. So what I did was I simply factored out the 2 first, then we remained with x squared minus 4 over 2 minus x. Then we know that the numerator is now a difference of two squares. It can be written as x plus 2, x minus 2. Now we say it's not possible for us to divide this one and this one because they have different signs. This one is positive, this one is negative, this one is negative, this one is positive. So what do? I factored out a negative in the denominator so that the denominator looks like the numerator x minus 2. Alright, then another thing, so from there they look the same, so I had to divide them. Then we ended up having the final answer is negative 2, open brackets, x plus 2. Alright. Alright, next question. C. Okay, so we have C now. 2x squared plus 7x plus 4. Okay. Everything over 2x squared plus 9x plus 4. Alright, so based on this question which I've written, what we need is we need the product and the sum for both of these. So we need the product and the sum for the two. So for the numerator, what's the product? The product for numerator is 8, the sum is 7. The two factors is negative 1 and 8, right? Because we know that, well, this is actually negative 4, right? Then for the denominator, so this one is for the numerator. Then for denominator, product is 8, sum is 9, the factors are 1 and 8. Alright, so replacing them, we have 2x squared minus x plus 8x minus 4, everything over 2x squared plus x plus 8x plus 4, right? Then if I factor out what's common, we have x which is common, then we have x minus 1, 2x minus 1, then plus 4 is common, then we remain with 2x minus 1 over x is common, 2x plus 1, then plus 4 is common, 2x plus 1. Okay, so the numerator becomes x plus 4, 2x minus 1 over the denominator x plus 4, then 2x plus 1. So as you can see, the x plus 4 and the x plus 4 will cancel, right? So the final answer ends up being, so the final answer is written here, 2x minus 1 over 2x plus 1. Right, so that's the final answer. So we needed to factorize the numerator and factorize the denominator. After factorizing the numerator, we ended up having x plus 4 to x minus 1. Factorizing the denominator, we ended up having x plus 4 to x plus 1. Then the x plus 4 and the x plus 4 are common, so I've cancelled them out. Alright, so that is that. Alright, that ends that question. Okay, so now I'm looking at D. Alright, I'm looking at D. D says 2x cubed plus 3x plus 5 over x plus 1. Alright, over x plus 1. So here what we are going to do is I'm going to use the long division method. 2x cubed plus 3x plus 5. Alright, so long division method, whenever you are using the long division method, you have to remember that you can only divide the variable, okay, but multiplication you multiply the whole thing with the whole divisor. Okay, so dividends divisor, then we'll have the quotient there. So now, the variable here is x, the one that is on the far left, okay? So what is x into 2x cubed? So x into 2x cubed is actually 2x squared, right? Then I'm now going to multiply 2x squared multiplied by the whole divisor, alright? So division, I simply said the x part alone into the 2x cubed, but multiplication, I'm multiplying everything. Alright, so 2x squared times x, this is going to be 2x cubed plus, alright? Then we have 2x squared multiplied by 1, that's just 2x squared. But one of the things that you will notice is that here, there's a squared which is missing, alright? So meaning that I could have actually written this numerator, I mean the dividend as 2x cubed plus 0x squared plus 3x plus 5, alright? So it's safe for you to write it like that whenever you are faced with such questions. So whenever you encounter such questions, I'm saying it is safe for you to write it like that, alright? So it is safe for you to write it like that. Okay, so whenever you are faced with a question where the highest powered variable or the degree is cubed or squared, whichever, but you notice that you are dividing, then the one that follows the highest is missing. Please, when you're using long division, include the 0, alright? So it's safe to include the 0. That's how we work around these things. Okay, so now we have subtracting. So this minus this is 0. 0 minus 2x, we have negative 2x squared, right? X into 2x squared is minus 2x, alright? Then I'm going to multiply this by everything. So we have negative 2x squared there. Then negative 2x times 1 is minus 2x. Alright, so here I'm going to bring down the 3, so plus 3x. Alright, so negative 2x squared plus 3x minus, alright? So minus becomes positive, so this is 0, but 3x minus positive, so this becomes 5x, right? So x into 5x is actually 5. Then 5 times this is 5x. There you have 5x. Then plus 5. Then bring down the 5. Then the answer ends up 0. Okay? So your answer ends up becoming 0. So that is that. Question 18. Alright, so question 18 says 3x cubed plus 12x squared plus 5x plus 20. Divide 3x cubed plus 12x squared plus 5x plus 20 by x plus 4 using, number 1, long division. Okay, so we're dividing by x plus 4. Right, so we're dividing by x plus 4. So using long division, you have x plus 4. Then we're going to write the actual polynomial in question. right? Okay, so what did we say? Division is for the variable. So x into 3x cubed is 3x squared. Right? Then x multiplied by that. So we're now multiplying this by the entire divisor. So 3x squared times x is 3x cubed plus 12x squared. Because 3x times that is 12, okay? 3 times 4 is 12, so we have that. Then subtraction, this is 0, this is also 0, so we have 0x squared. Right? Then, x into 0x squared, x into 0x squared. So it's like I say in 0 over x, what do you get? You have a 0, alright? So plus 0 x, okay? So now, when you multiply by that, you actually have zeros. Alright, so we're saying 3x squared times 3x times x squared is actually 3x cubed. Then 3x squared multiplied by 4 was 12x squared. When you subtracted, we had a 0. This into that is 0x. Then now we have 0x multiplied by this. This is actually still 0. So we have 0x squared plus 0x multiplied by 4. So we have 0x. Alright? Then we bring down the 5. Subtraction, 5 minus 0 is 5x. Alright, so x into 5x is 5. Okay, then what is 5 times x? 5 times x is 5x. We have that. Then what is 5 times 4? 5 times 4 is 20. Then bring down the 20. When you subtract, this is 0. Okay? So that is that. So that's how you find that. So we're saying whenever you have something of this nature, do not be afraid that it gave you a 0, right? Because we know 0 over any number is still 0. So this is why I said x into 0x squared, the answer was still 0x, alright? Then 0x multiplied by x squared is 0x squared. Okay, then we have 0x multiplied by 4, which is actually 0x. Then here subtraction, I had to bring down the 5x, then I subtracted. 0 is 0, 5x minus 0 is 5x. Then x into 5x is 5. Then 5 times x was 5x. 5 times 4 is 20. If you subtract the 2, you actually have 20 minus 20, which is just what? 0. Alright, so that is how you find your answer. So now that's by long division. The next question is saying by synthetic. Alright, so one thing I should also tell you is take note of the quotient. The quotient is 3x squared plus 0x plus 5. Whether I use long division or the synthetic division, I expect to have the same answer. So regardless of the method I use, I expect to have the same answer. Right, so let's use the synthetic method. So, part 2 says synthetic. Synthetic division. Alright, so synthetic, the first thing that I'm going to do is I'm going to say x plus 4 should be equal to 0. Alright, so that we have x being equal to negative 4. So this negative 4 is what I'm going to use in my synthetic division. So synthetic division requires us to draw something like this. Okay, then I'll put the x, which is negative 4, or the constant, this side, negative 4, alright? Then I'm going to write the coefficients of the polynomial given. So now I'm going to write the coefficients of the polynomial given. So the polynomial that we've been given, we have 3, we have 12, the coefficients 5 and what? 20. Then whenever you're using synthetic division, the first one you always retain it, okay? So I'm going to rewrite 3 here. Okay, so the coefficient of the highest powered variable in the polynomial is retained, okay? So regardless, we still retain it. So doing that, you will notice that now I'm going to start multiplication. So how do I do the multiplication? So it's negative 4 times 3, but I don't write the answer here. I write it on the next, okay? So negative 4 times 3 is negative 12. Alright, then I'm going to add this to 12 plus negative 12 is what? 0. Can you see that? Alright, then negative 4 multiplied by 0 is 0. Then I'm going to add 5 plus 0, which is actually 5. Then negative 4 times 5 is negative 20. When you add, it's 0. Alright? So we're saying that we first write the coefficients of the polynomial given. Then after that, we retain the first coefficient of the polynomial. So the first coefficient was 3, so I retained it. Then I multiply 3 times the number, the x or the constant which you have here. I equated the divisor to 0 so that the x we have is negative 4. Okay? So always equate the divisor to 0. Alright? So the divisor is x plus 4. So x plus 4 is equal to 0, then x is negative 4. This constant here is the one I always put here. Alright? Then I retain the first coefficient, which was 3. Then now multiplication, when I multiply the 2, I put it under the second coefficient. So negative 4 times 3 is negative 12, then I add. So addition is what's taking place here. 12 plus negative 12 is 0. Negative 4 times 0 is 0. I write it on the next. Okay, then 5 plus 0 is 5. Negative 4 times 5 is 20. 20 minus 20 is what? 0. So that is that. Okay, now these numbers which we have here, these are the coefficients of the quadratic equation, okay? Or it is the coefficients of the polynomial that is the lower degree, that is by 1 degree lower than the one that you had in the first place. So if this was power 4, then this will be power 3. If this is power 2, this will be power 1. Alright, so the reduced polynomial is the quadratic in this case. So these are the coefficients that we have. So the coefficients are 3x. So the first highest is 3x squared plus 0x plus what? 5. So this is what we had when we used long division. Alright, so I'm saying these here are the coefficients of the resulting quadratic equation if you have a cubic polynomial. If you had a polynomial raised to the power 4, then meaning these would be the coefficients of the cubic function. Alright, so the cubic polynomial, because just because it's a polynomial doesn't mean it's a function. Alright, okay, so that is that. Okay, so what if we tried to use synthetic division on the previous question we did? Remember we did some question that this question here, 2x cubed plus 3x plus 5 was being divided by x plus 1. Alright? So we have the dividend, we have the divisor. So we can use synthetic method even on this question. Alright? So how do we do that? So I'm going to say the divisor should be equal to what? 0. So x is equal to negative 1. Negative 1. Then this is the dividend. So I'm going to draw something like this. Then what I'm going to do is now we're going to write the coefficients of the dividend. So here we have 2, we have 3. No, actually there's a 0 missing because after x cubed is x squared, so meaning there's a 0 here, okay? Then we have 3 from the x, then we have 5. Alright, then what did I say? We need to write the constant this side, so the constant x is negative 1, so that's the negative 1 I've written there. Right, so now from here we're going to retain the 2, I've retained it, then multiplication, negative 2 times 2 is negative 2, so negative 2 plus 0 is negative 2, right? Then negative 2 times negative 1 is positive 2. 3 plus 2 is positive what? 5. Then from here, we have negative 5 times 5, which is negative 5. If you add this 0, so the resulting polynomial from this is actually 2x. Remember, this is a cubic polynomial, so meaning this should be a quadratic polynomial. So it's raised to the power 3, the next one, the lower one is raised to the power 2. So 2x to the power 2 minus 2x plus 5, okay? So this is what we had as the reduced form even before. Right, so we have 2x squared minus 2x plus 5. So that is what we had. Even when we were using long division, that was the answer that we found. So you can either use synthetic or you can use long division, right? So that is how you find that. Alright, so that is just how we go about these questions whenever you are talking about division of such. So let's look at another question. Let's look at another question. Alright, so we have question 19. Alright, so probably maybe we'll go up to 20 if time allows. So these questions are fun. If you enjoy them, you can get them. So let's look at question 19. Show that x minus 3 is a factor of 2 that 2x cubed. So we've been told that show that x minus 3 is a factor. Okay, it's a factor of 2x to the power 3 minus 2x squared minus 17x plus 15. So we need to show that that is actually a factor. All right. So how do you show that this is a factor? For us to show that that is actually a factor, we need to use the factor theorem. All right. So if you use long division or synthetic division, if this is divided by x minus 3, then what we get to have as the remainder should be 0. Right? So let's use long division since you guys are just getting to learn long division. So x minus 3, I'll use long division. So if the remainder ends up being 0, then we know that this thing is a factor. If not, then it's not. You can't force things unless maybe we made a mistake. But if we say show, maybe it's a fact. So, okay, show that that is a factor. So it's a fact. X minus 3 is already known as a factor, but they just want you to show, all right? So showing, we either use long division or we use synthetic, but we're saying the remainder should be what? 0. Now, whenever you hear words like verify, show, know that those are facts. The answer was already the question. The question is the answer, okay? But we need to see if you are able to show. So we've been asked to show that x minus 3 is a factor. So meaning that it's already a factor in that question. So it's just up to us to show if the remainder is going to be 0. Okay, but that's not always the case. No wonder we are asking you to show and verify, because it may not always be the case. So x into 2x squared, 2x cubed is actually 2x squared. Okay, now the beauty of long division is that you notice I would have answered the whole question at the end of it. All right, that's the beauty of long division. We'll end up answering the whole question. Okay, so x into 2x cubed is 2x squared multiplied by that, so we have 2x cubed. Then 2x squared multiplied by 3 is minus 6x squared. Then subtraction, just like grade 5. Okay, yeah, maybe grade 5. Yeah, grade 5. This minus this is 0. Negative 2x squared minus minus. Okay, so minus minus. So we have negative 2x squared minus minus. So minus minus is positive, right? So we have 4x squared, right? X squared into 4x squared is 4x. So x into 4x squared is 4x. 4x multiplied by this, we have 4x squared minus 4x times negative 3 is what? 12x. Then bring down the 17x. Then what are we doing? We are subtracting. So now since it is subtraction, 4 minus 4x squared is 0, and then we have negative 17x minus positive, so it's like negative 17 plus 12, which actually ends up being a 0. Alright, so negative 17 plus 12 is negative 5x. Okay, so x into negative 5x, what do we end up having? We end up having a 0. Not true? Yeah. So x into negative 5x is actually negative 5 from here. Then negative 5 multiplied by that, we have negative 5x. Then minus negative 5 minus negative times negative 3 is positive 15. Okay, so plus 15, bring down 15, then we have 0. Yeah, because negative 5x minus, it becomes positive, so negative 5 plus 5x is 0. And then we have 15 minus 15, which is actually 0. So that's the answer, okay? So that's the answer which we have. We have a 0. So now that we have a 0, that's our conclusion. It is a factor. Remember that a number is said to be a factor if when you divide into that number, the remainder is 0. Not so. If I said give me the factors of 8, we're simply asking for numbers that can go into 8 without leaving a remainder. So I mean the remainder is actually 0. Example, 2, 4, and 8 itself. So 2 into 8, it's 4, remainder 0. 4 into 8 is 2, remainder 0. And 8 into 8 is 1, remainder 0. So basically speaking, 2, 4, and 8 are factors of 8, meaning these numbers can go into 8 without leaving a remainder. Okay, so if that is the case which we have, it's the same thing here. For x minus 3 to go into this and does not leave a remainder, it simply means that x minus 3 is actually a factor. Okay, so that's that. Alright, next part of the question, we have been told that hence express that in the form x minus 3 multiplied by that, where the values of a, b, and c are to be found. Wow. Okay, so what I'll do is I'll keep this. I'll keep the answer here, 2x squared plus 4x minus 5. Okay. So as I said before, you will notice that by using log division, I've answered the question completely, right? I've answered the question completely because we've been told that we need to express 2x cubed minus 2x squared minus 17x plus 15, okay? And this should be in the form x minus 3 multiplied by ax squared plus bx plus c, right, where a, b, and c are to be determined. So if you look at this, you notice that when we divided, wow, if I divide both sides by x minus 3, okay, even this side by x minus 3, okay, so if I divide both sides by this, what do you notice? You actually notice that ax squared plus bx plus c is actually equals to 2x to the power 3 minus 2x squared minus 17x plus 15 over x minus 3. Okay? Now, I've already divided this. Alright, so what do you find? ax squared plus bx plus c. When we divided this into this, what was the quotient? The quotient was this. 2x squared plus 4x minus 5. So that was the reduced. Okay? So from this we can actually determine that ax squared is equal to 2x squared. Therefore a is equal to 2. Then we have bx is equal to 4x. So b is actually equal to 4. And we have c is equal to -5. Right? So that's the answer. That is what we get as our final answer. Now you will realize that these are actually one and the same questions. Alright. Question 19 and question 20. The logic is the same. Okay, so for today we end here. So as a summary, we said the first thing we needed to show. So in showing, I used the long division. If we wanted, we would have used synthetic. Okay, so using the long division method, we actually noticed that 2x cubed minus 2x squared minus 17x plus 15 is equals to that. Okay, then from there, what we now did was we had to divide both sides by x minus 3 and x minus 3. So what I did was, this is the question. Okay, this is the question. Then we know that it can be expressed in that form. Okay, where x minus 3 is to be determined. So we needed the value of a, b, and c. Alright, so I simply divided both sides by x minus 3, x minus 3. So overall speaking, we can actually conclude to say this part here, which I'm writing here, 2x cubed minus 2x squared minus 17x plus 15 is actually equal to x minus 3 multiplied by 2x squared plus 4x minus 5. Okay, so I've written it in that form. Right, so that ends our tutorial. So remember this part here, let's write it down here, x minus 3, 2x squared plus 4x minus 5. Okay, we have 2x3 minus 2x squared minus 17x plus 1, 15. Right, so that is what we have there. That's the final answer. Alright, so that marks the end of our tutorial. Have a good day.